Welcome viewers. In this video, we'll see the solved problem based on the sinusoidal response of RC circuit. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Sinusoidal response of RC circuit. Resistor and capacitor is connected in series. In that we need to find the transient current. So this is the circuit given. Resistance 5 ohm. Capacitance 0.5 Henry connected in series. It's connected with the switch S. The applied voltage is exponential 5 e power minus t. So this is the transient current I of t flowing through the circuit. Now we'll see the statement of the problem. An exponential voltage V of t equal to 5 e power minus t is applied at the time t equal to 0 to a series RC circuit comprising R equal to 5 ohm, C equal to 0.1 farad. So 5 e power minus t voltage is applied at t equal to 0 to the RC circuit. Obtain the complete particular solution for current I of t through the capacitor. Assume zero charge across capacitor before application of driving voltage. So we need to find the transient current across the capacitor. There is no charge available before closing the switch, zero charge. So that is the condition given. So based on that, we'll go to that. Now first we need to frame the equation for the given circuit by using the Kirchhoff's voltage law. In time domain, the equation of the circuit is given as using the Kirchhoff's voltage law. Applied voltage equal to voltage drop across resistor and capacitor. Otherwise, voltage rise equal to voltage drop. So based on KVL, so this is applied voltage V of t equal to R into I, voltage drop across resistor. 1 by C integral minus infinite to 0 I dt. This is the initial charge available across the capacitor, minus infinite to 0. The switch is closed at 0. So 0 to t, 1 by C 0 to t I dt. So this is the voltage drop across the capacitor after closing the switch. So that is equal to V of t. Now substitute all the value. R is 5. So 5I plus initial charge is 0 given in the problem. C is 0.1, 0 to t I dt equal to 5 e power minus t. Right. So the applied voltage is exponential 5 e power minus t. So that 5I plus 1 divided by 0.1, 0 to integral 0 to t I dt equal to 5 e power minus t. So our aim is to find the transient current. So first we will take the Laplace transform of this equation so that t domain will be converted into S domain. After simplification we need to take again inverse Laplace so that we will get the transient current of the given circuit. So take Laplace transform on both the sides. So 5 is constant, Laplace of I is I of s plus 0.1 is there. Integral 0 to t I dt. The Laplace of this integral is I of s divided by s. That is equal to 5 is constant, e power minus t. Integral, the Laplace of e power minus t is 1 divided by s plus 1. That is e power, that is based on e power at equal to 1 divided by s minus a. Right? S minus a. Here s plus. Here minus, right? So e power minus at equal to 1 divided by s plus a. A is nothing but here 1. So here e power t is equal to s 1 divided by s plus 1 based on this formula. Now we'll take I of s common. So I plus 5 plus 1 divided by 0.1 s equal to 5 divided by s plus 1. So this 1 divided by 0.1 is written as 10 divided by s. Right. Now we'll go for the LCM. We will take the LCM here. So here it is multiplied by 5s. So 5s plus 10 divided by s. Now we'll bring this term in the denominator of the other side. So that we'll get the expression for I of s. So that I of s equal to 5 divided by s plus 1 into s divided by 5s plus 10. In order to bring this, we can take this 5 outside. We have to bring the form s plus. The standard form is s plus. Here already available s plus 1. So 5 is taken outside. So s plus 2. The 5 goes 2 times. this 5 got cancelled. So S divided by S plus 1 into S plus 2. So equation 1. We'll take this equation 1. In order to take the inverse Laplace, this would be converted into partial expression technique. We have to split the terms so that we can take the inverse Laplace transform. So by partial expression technique, the above equation can be written as k1 divided by s plus 1 plus k2 divided by s plus 2. So by using the partial expression technique, it is splitted. This expression can be easily, we can take the inverse Laplace, but we need to find the value of k1 and k2. Right. So this equation is now written like this. So both are equal. S divided by s plus 1 into s plus 2 equal to k1 divided by s plus 1 plus k2 divided by s plus 2. Now we'll go for the further simplification. Now we'll take the LCM, this s plus 1 into s plus 2. Here only s plus 1 is available, so multiplied by s plus 2. Here s plus 2 is available, so multiplied by s plus 1. So these two terms available on both the sides got cancelled. So s equal to k1 into s plus 2 plus k2 into s plus 1. Right. Now the next step is we need to find the value of k1 and k2. We have to select the s value such that the term got cancelled. For example, s equal to minus 2 means this term got cancelled, so that we can find k2. If s equal to minus 1 means this k2 got cancelled, we can able to find k1. So select the s value such that it will cancel any one term. So based on that, s equal to minus 2. We have to substitute s equal to minus 2. So s is minus 2 equal to k1 minus 2 plus 2 plus k2 into minus 2 plus 1. So this term is 0. So minus 2 equal to minus 2 plus 1 is minus 1 minus k2. So k2 equal to 2. Now we calculated the value of k2. Now substitute s equal to minus 1. Minus 1 equal to k1 minus 1 plus 2, k2 minus 1 plus 1. Thus this term is 0. So minus 1 equal to k1, so k1 equal to minus 1. Right. So select the value such that it will cancel any one term. Now we calculated k1 and k2. Now we can substitute this value. So this is equation 1. In this we are going to substitute the value of k1 and k2. So k1 is minus 1, k2 is 2. So minus 1 divided by s plus 1, 2 divided by s plus 2. Now we'll take the inverse Laplace on both the sides. Right. So minus 1 is constant. 1 divided by s plus a is nothing but e power minus t. 2 is constant. 1 divided by s plus 2 is e power minus 2t. The formula is 1 divided by s plus a equal to e power minus at. Here plus mean minus. Right. So first case a is 1. So that e power minus t. Second case a is 2. So that e power minus 2t. So here minus 1 into e power minus t plus 2 into e power minus 2t. We can rearrange. 2 e power minus 2t minus e power t, e power minus t. So this is the final expression for transient current. So current flowing through the circuit. So in this video we discussed the solved problem based on the RC circuit, resistor and capacitor. We obtained the transient current, expression for transient current. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.